Hello, this is part 2 of section 9.2. And the first thing we're going to do is come up with the sum of an arithmetic sequence. So if it's an arithmetic sequence, that means it's a sub 1 plus n minus 1 times d. Oh, I want to use I though instead of n. And we're taking the sum of I equals 1 to n. It's important that we start at 1, and when you take the sum of this will equal n over 2 times a1 plus n minus 1 times d. Now, I did go over the proof of this on the optional Zoom call, but if you are curious about the proof, you can find it in the textbook as well. And then for the geometric sum, the sum of I equals 1 of n of a1 times r to the I minus 1. This is going to equal a1 times 1 minus r to the n over 1 minus r. Now the reason for this is because sometimes you're going to be doing these sums where you are adding 20 terms together. So you don't want to do what we did in example 1, where you write out all the terms and add them. This is going to be a shortcut method. So for example, for the sum 1 plus 3 plus 5 plus 117, well, we already came up with this. This was the sum of n equals 1 to 59 of negative 1 plus 2n. That's what we did in example 2. But we also said this was arithmetic. So because it's arithmetic, instead of figuring out all 59 of these numbers, I can use the shortcut, which says we take n, which is 59, divided by 2. 2 times a1, a1 is the first term, so 1, plus n minus 1, so 58, times d, which was 2. And if you calculate that out, it comes out to be 3481. Now for B, I would write out the first few terms in case you don't recognize if this is arithmetic or geometric. So this is 1 plus 2 plus 3 plus ... plus n. So I'm hoping you see that it is arithmetic with d equal to 1. So according to our formula, it'll be n over 2 times a1, or 2 times a1, sorry, plus d, or n minus 1, sorry, times d. So that's from our formula. And if you simplify some things, this will come out to be n times n minus 1 over 2. So in other words, if somebody ever asks you to calculate the sum of the first 200 integers, you go 200 times 199 divided by 2, which is 100 times 199, so 19,900. So it gives you a shortcut for adding integers together. Now for C, I'm hoping you notice that it's geometric because you multiply by 1/3 at each step. So then our sequence is 1 times 1/3 to the n minus 1. Now I'm real curious for when 1/3 to the n minus 1 is equal to 1 over 177,147. Well, this is 1 over 3 to the n minus 1 equals 1 over 177,147, which is 3 to the n minus 1 equals 177,147. And this is why it's good to know about logs. We can take the log base 3 of both sides to solve this. So n minus 1 equals 11, so n will equal 12. Now the reason why that's important, and I'm actually going to erase it because I'm going to need this room back, but it's just important to know that n equals 12, is now when we do the sum, we're doing the sum of 1/3 to the n minus 1 from n equals 1 to 12. This is geometric, so that'll be the first term, times 1 minus 1/3 to the 12th power over 1 minus 1/3. And if you calculate that out, you get 265,720 all over 177,147. Now for D, this, again, if you don't realize what type of sequence 2 to the n is, you just plug in 0, so you get 1, plus 2, plus 4, plus 8, plus ... plus 2 to the 63rd power. So this is geometric with r equal to 2. So you might want to use the geometric formula right away, but unfortunately, we can't because it's starting at 0. So what you have to do is what's called a change of index. And instead of going through a change of index, pretend like you started out with the list and come up with the new sequence. Because if we start out with the list, A1 is equal to 1, D is equal to 2, so then our sum is n equals 1 of A1 times 2 to the n minus 1. And n minus 1 equals 63 when n is 64. So this is called reindexing. And now I can say that this is equal to the sum of n equals 1 to 64 of 2 to the n minus 1, which is 1 times 1 minus 2 to the 64 over 1 minus 2, which comes out to be 184467440737009. 551615. So quite a large number. And that's it for section 9.2. Again, don't forget to do the highlighted problems out of this section.